The final integration technique that we're going to look at is integration by parts, and this one is very closely linked to the derivative of using the product rule. And in fact, we're going to use the product rule for derivatives to show how the integration by parts formula comes about. You see on your screen there, I've taken a snap of the formula booklet for the specialist mathematics. So this formula is given to you in the exam. And I'm just going to quickly run through how the formula comes about. You don't need to know this, but it's not a bad exercise to run through just so you can see where it derivates from. So if we start off with our product rule, as we know, the product rule, if you have a function that is a product of, two other functions, so let's say u is a function of x and v is a different function but also of x, then we can find the derivative by applying the product rule. So that's u times dv dx plus v times du dx. So I'm just going to rewrite the dy dx part because I'm just going to replace y with the fact that it's the product of u and v. So the u dv dx plus v du dx. And I'm just going to rearrange that formula. So I'm going to say that u dv dx is going to be equal to du uv times over dx minus v du dx. I've just taken the term on the left here, on the right side, this term here, and I've just transferred it to the other side of the equation. Now, if I take the integral of everything, so if I integrate everything with respect to x, integrate that with respect to x, integrate all of that with respect to x, then we've already identified that the integral of u times dv dx with respect to x is going to be the integral of, the integral of the derivative of uv. So if I integrate the derivative of uv, I just get uv. And then I can subtract away the integral of v times du dx with respect to x. And that's my product rule. So what we have here is the product rule in uv form. Okay, now sometimes it's written as a shortcut, or shorthand, it's just written as the integral of u to v is uv minus integral of v du. And that's the shortcut way of writing it. We've just left off all the dx's, but we're assuming it doesn't matter if it's dx to t, it doesn't make any difference. Let's have a look at an example. So we want to find the antiderivative of x cos x. Okay, so it doesn't tell you what process we want to follow. Obviously, we're going to be using integration by parts. It doesn't seem to be a substitution problem or an inverse trig function or anything like that. So we're going to have a crack at integration by parts. Well, we know our formula is u to v dx dx, the integral of u to v dx dx is equal to uv minus the integral of v du dx dx. So if you look at the form, we've got, and I'm just guessing for the moment that they're going to be that order. Now, it doesn't have to be, okay? Sometimes you might assign the first function as the v dx. It depends on what you need to do with it. And we'll look at what that would look like in a moment. So if I'm going to make the assumption at the minute, right, just put it there so it's out of the way. So I'm going to let u equal x, and I'm going to let the v dx equal cos x. Okay? And so I've made that assumption. Sometimes it might not work out and you have to swap them over, but we'll see how this one goes. So if I look at my formula, I need four things. I need a u, I need a v, or three things. I need the v again, and I need du dx. Okay? So, do I have u? Yes, I do. Do I have v? No, I don't. Can I get it? Yes, I can. The v dx is cos x, so the integral of cos is sine. Okay? And then I go, all right, I've got v already. Du dx, well, that's just the derivative of u. So I can find that quite easily. That's a good thing. Notice that that reduces down to a function that I can integrate easily. Okay, I don't want that one to get worse. All right, so that's a good reason to choose a function. So of the two, x and cos x, if I can identify one that will become simpler when I find its derivative, Therefore, it'll become easier to integrate, as you can see over here. I've got to integrate to u dx, so if it's simpler to do, then that's the one I choose. So let's keep going. So let's substitute in what we need. So this is going to be the integral of x cos x dx. So that's going to equal to u times v. Well, u is x and v is sine x, minus the integral of v, which is sine x, times du dx, and du dx is 1. So it drops off. And now notice, the only thing I have to integrate is the sine x. This is already integrated. I don't need to touch that apart from rewrite it. Okay, minus, what's the integral of sine? Okay, it's negative cos. Cos c. And so if we end up with our solution, x sine x plus cos x plus c. And there's my solution. That's my integral of x cos x. Okay. Now, if you were asked to check the reasonableness of that solution, which is unlikely, but if it was, what could you do? Well, you differentiate this, you differentiate the answer and see if you get back to your original function. Okay. Now, what would have happened if I'd done it the other way around? What if I'd chosen that u was the cos x and the v dx was the x? What if I'd chosen the other way around? Okay, so this is a what if. What if? So following the formula, I need to do u dx. So the derivative of cos is minus sine x. Okay. And the v dx is x, so then v would be x squared over 2. Okay, so looking at my formula, okay, and keeping in blue the what if, so x cos x dx would be equal to u times v, so it'll be u cos x times v, which is x squared on 2, minus the integral of v, which is x squared on 2, multiplied by du dx, and du dx is minus sine x. Let me just get rid of this line now. It's in the way. Integral of sine x dx. Notice what's happened here. It's not any simpler. Now, sometimes that will happen, and we can get around that, and that'll be in a future example. But for the moment, that's not any easier to do. So what that might do is there's two things I need to consider. If I swap them and go back to what I did originally, would that make it easier? In this case, obviously it does. But if it doesn't, then there's another process that will follow, which will be in a future example. But this doesn't help. Whoops. So if I just write that, so it doesn't make it easier, therefore swap u and v dx. Okay, that's what we try. So this is a big what if scenario. What if I'd chosen the other way around? Okay, I chose right the first time, which is great, but sometimes you don't. So be aware that it's okay that if you get it wrong, you can try something else. Okay, so let's try this second example. So let's just put a big line down here, and we'll have a look at this one. Now, we want to find the integral of arcsine. Okay, so how do we do that? Alrighty, so integral of arcsine. Well, it doesn't fall into any of our problems that we've done so far. All right. If we go back and have a look at our derivatives of inverse trigonometric functions, we've got the integral of functions with, as rational functions gives us arcsine, arccos, or arctan, but we haven't actually done where we actually integrate arccos, arcsine, or arctan. So therefore, those have that work. So we need to think of something else. Now, obviously, we're in this section about integration by parts, so let's try that solution. Well, we know that integration by parts is integral of u to v dx is equal to, dx, sorry, is equal to u v minus integral of v to u dx. Now, as we said earlier, we've got two parts to this. Sine x. Now, we don't know how to integrate arcsine x, so it would be pointless to choose it as our v dx part. But we do know how to differentiate it. Okay, we do have a rule for that. So if I come across here, okay, so we can identify that u is equal to something. So that'll be u will be arcsine x, because we can find u dx, because we need that from our formula. And if you think back to your tables and all your work, The derivative of arcsine x is 1 over the square root of 1 minus x squared. Okay, so just keep that in mind. But what the heck is d v dx going to be? Okay, can we do that? Is there anything we can do to solve that problem? Well, what is d v dx in our example over here? Well, there's no other function, so it must be equal to 1, which means that v is equal to x. Now we've got the bits that we need. Okay, so now we're going to solve this problem. So it's going to be u times v, so it's going to be arc sine x times v, which is x. So I'm going to write that at the front. Okay, so it's x times arc sine x. I'll put that in brackets just so it doesn't get lost. Minus, excuse me, integral of v, which is x, times du dx, which is over 1 minus x squared dx. Okay, so we've got x arc sine x. Now we've got this. Can we integrate that? Well, actually, we can. And that's what I'm going to... So if we're going to integrate this, we're going to use another method that we've learned earlier. So integration by substitution. Okay, so we're going to integrate by substitution. So let's come over and do that. Integral of x over 1 minus x squared dx. Let's pick a different variable. Let's call it w is equal to 1 minus x squared. So do w dx is equal to negative 2x. So dx is, pardon me, the w over negative 2x. So therefore the integral of x over square root 1 minus x squared dx is going to be equal to the integral of x over the square root of w times, we're going to replace dx with the w over negative 2x. This equals, so the x's will cancel, so we're going to do the integral of negative 1 over w to the power of a half multiplied by, to w, and we can integrate that and we're going to get, let's think this through, so it's going to be negative 1 over 2 times w to the positive half. That's actually not going to be, is it going to be 1 over 2? Let's not rush it. Let's go back, let's not rush it. So it's going to be integral of negative w to the minus a half w. So if I do that properly, that's going to be the integral of, so negative w to the positive a half over positive a half, or get rid of the equal sign, which equals negative 2w to the power of a half. There, we made a mistake. I think I have. Yeah, that's fine. Okay, so if we come back now, that means that the bit in black minus, and then the negative, so it's going to be negative, make that a bit small so I can see it, minus 2 square root 1 minus x squared. And the two negatives will actually cancel, that minus there and that minus, we go with that. So this is going to be x arc sine x plus 2 square root 1 minus x squared. Now that was a very long and challenging question, so that's definitely complex familiar, okay? But what you can see is the process that's followed. Okay, so I'm going to leave that video there with those two examples.